Hello. This is a small review of a little project I'm working on, which, as you can see, looks wonderfully chaotic. Underneath all this chaos is actually a very simple project. The little board that you can see there is a USB LED strip controller. So there's a LED strip control connected there. You can see the frame rate of the LED light that we have here. I'm very sorry about that. Essentially, the LED strip there is supposed to be connected to a little box, which is a little plastic box like that. These are sold in the local Action store here in Holland. And the little controller normally has a small 8-pin microprocessor there, which is able to drive these three little field effect transistors and listen to an infrared receiver, which is currently positioned there. I'm a bit careful with the circuit because it's actually live. It's connected via a power cable here, which is basically a USB to barrel connector, nothing special. The barrel connector has been tapped so that the power for the whole thing goes towards the original circuit, as well as this little power board there, the blue one in the back, which is basically a small 5 volt to 3.3 volt converter. It's a switch mode power supply. They cost absolutely nothing on AliExpress. When you buy one, you will need to make sure that you buy one which can have a minimum input voltage of 5 volts. Some of them start at 5.6 volts. They are not useful. What I did is I removed the 8-pin microprocessor. I found the 3 pins which are responsible for the R, G, and B outputs, which basically are little lines across the board which go through a resistor each, and then end up with one of these transistors each, which drive the LED strips which are there. The other thing I did, which is harder to spot, is I cut a little line there so that this trace here towards the power in, the positive voltage of the infrared receiver, is connected to the same voltage as the little as the output of that power supply, so the switch mode power supply. So it's 3.3 volts. This thing is fed 3.3 volts, which means that the signals that come out of it are also 3.3 volts. Why did I do all that? Well, the little thing on here is an ESP8266, which has been programmed with ESPHome firmware, which I'll demonstrate in a moment. And the resistors on the back are the usual quote-unquote resistors to get this thing to run after you've programmed it. So I use a little frog pin test bed, which I have here, which is a little device you can buy on AliExpress. There's an original on Tindy as well. They cost about 6 to 8 euro, I think. Basically, you push in an ESP12 board. You're able to turn it on and off with this switch. It has a serial chipset USB, and you can program it with ESPTool or whatever tool you want that is included with your development system. The ESP8266, as I said, is programmed with ESPHome firmware, and it has 3 connections to the 3 RGB lines, and it has 1 connection, in this case on IO pin 5. You can see it very slightly there, which makes sure that the thing has an input for the infrared transceiver. So it's IO pins 12, 13, 14, which are randomly connected to R, G, and B. I really have no clue which are what, but I'll fix that later in firmware, in the definitions of the code. The reset and enable line are all pulled to plus 3 volts, and the IO 0 line is also pulled to plus 3.3 volts, so basically VCC. And then there's a very sneaky resistor, which I will show, which is there, it's standing upright, which is connected between ground and IO15. I forgot what IO15 did. Let me see if I can find, yeah, it's basically this schematic, nothing special. I forgot what IO15 was supposed to do. I think it's the one that bootstraps the thing so that it will read from ROM instead of from some other source. I really have no direct clue, but this seems to work. I skipped the 100 nanofarad thing because the lines are not that long, and it seems to work so far. I'll fix that in post if it turns out to be a problem. This whole thing with a little bit of insulation tape, a little bit of shrink tubing, and some sweat and tears will probably fit in the original box. There's a backplate as well. That means that I can then control the whole thing via Wi-Fi. Because the 8266, as you might know, is a Wi-Fi chipset, there's ESPHome firmware, which allows convenient programming of these types of devices. It provides, in this case, a web UI, which I defined, and the web UI currently has one single thing. It has a toggle button, and if I click on the toggle button, it will glow or unglow all 3 channels at the same time. I have yet to define a red, green, blue definition or whatever. But one other thing that's working, which you'll see there, is when I start pushing buttons on this remote, I have it wired up so that it will actually relay exactly what kind of commands it received from the infrared control. This allows me to figure out what the command strings are for all these buttons. I'm sure somebody else did it before, but then I can start using the ESPHome automation stuff, or the command stuff, I'll have to read up on it, to basically say, hey, the moment somebody presses the R key, I want to have a switch called red, and the switch called red should activate some kind of state in the RGB light that's there, because that thing has been defined as an RGB light. Currently it turns all channels on and off at the same time, but the final intention is to have this be something that actually will work with a remote control if you want, but more importantly, in this case, because it has USB and it will have Wi-Fi, and it all fits in a little box, and it's actually designed as a USB LED strip to fit behind the television screen. So it's designed to be mounted behind a television screen as a kind of decorative light. What I'm going to use it for is like a status indicator for things that are going on that screen. We have a use case for this at the moment. And this makes it really convenient to do that. Another way would have had been to basically do nothing with the circuit and find some way of controlling an infrared LED from a PC, and thus control the whole thing via infrared. Of course, that would work fine. Problem is, you cannot read the state that the LED strip is in at any moment. So if somebody turns it on or off, you have to remember whether or not it's on and off. So with the Wi-Fi stuff, you can actually see what the state is. Second of all, anybody can get these remote controls, so there's no way of actually protecting against people fucking around. And the default state, or the default functions of the remote control also allow for strobing, for flashing, for color cycling. So there's all kinds of weird stuff that you kind of don't want people to just dick around with, and yeah, change your nice settings. I think the total cost for this project is about $1.50 for, well, €1.50 for the ESP, about 93 cents for the switch mode power supply, some wires, and of course the LED string itself, which is I believe $5.95 at the Action right now. This is, by the way, not paid promotion. I don't get any money, but I think it's a really nice way of extending this type of thing. Biggest challenge right now is to figure out how to get this in here without too many live wires touching each other. Shouldn't be so much of a problem. Duct tape is our friend, and if not that, yeah, let's see what we come up with. So yeah, that's it. I hope this is useful to somebody, or can inspire other people. I will change the I will show some code if I can find the right window. Yeah, so this is basically what it is defined as at the moment. There's a couple of things to note. There's a light, there's the GPIO pins which are used by the light, and there's the remote receiver. Important for this one is to have it inverted true. If you do not do that, most of these types of receivers, which are these 3-pin devices, basically will not work. The dump all stuff is to dump all the output from that thing to the logs of ESPHome, so you can basically debug it, but you can also see the codes, and the codes seem to be the LG type, but you'll find that out once you start playing with this. This inverted thing was the most important missing thing from the project for a long time, because yeah, I tried all kinds of combinations, but that made it work for me. So yeah, have a good time playing around with this type of thing, and let me know if you made something cool. Ciao!